Adam, hi. I just saw your message in the chat. Thanks for being here. Glad you're here.
Thanks for having me.
You're the first one here. This is great. Usually we have a few people on. I was getting a little confused.
Just very excited.
Oh, outstanding. I saw you watched the video. That's great. Do you mind telling me a little bit about yourself? What brings you here?
So I spent a lot of time in identity and access management for SAP. And now I've got like more of a generalist consulting cybersecurity role, and have realized there's so much I don't know. So much.
A lot of things to know. Holy cow.
Yeah. So I've got my CISSP exam in 2 months.
2 months.
And I am freaking out.
Well, no need to freak out. You're in the right spot. Do you have some resources you're using? Hi, Paul. Good to see you here.
Yes. So pretty much all the general ones. I started reading the book and just found it really arduous and hard. Probably only got up to about chapter 8.
Yeah.
And now I've been basically like watching videos. The destination certification videos have been really great.
Good.
I've got a little study session at work, so that's very helpful.
Oh, nice. You studied with some other colleagues or peers?
Exactly.
Wonderful. That makes such a big difference, especially if it's in your day job where you get to interact with them more. That's great.
Exactly. And yeah, I did one of the Thor Peterson practice exams, one of the easy and medium ones, and I got exactly 70%. So yeah, but like I'd like to do better. Like especially like I started one of the hard ones and like immediately seemed too hard. So yeah, there's some work to do.
Well, good. There's always work to do. So I'm glad to have you here. That's awesome.
Thank you.
April, good to see you here. Sandra and Cheryl. I got my crew. I love having you on here.
Yeah. Hi, Josh. How are you?
I'm doing well. How are you, April?
Pretty good.
Good. Paul, how has studying been going, my friend?
Oh, it's going pretty good. I'm trying to bump it up a little bit. This is my last week for just doing 50 overall questions. I think next week I'll be doing 100, and from here on out. So
excellent. Okay.
It's going pretty good. You know what's helping, and this is for anyone that's listening. Of course, we take the exams and we try to keep going, but actually reading and not listening to like tapes and YouTube and everything, literally going back to the book and reading it.
Mm-hmm. Yeah.
It's weird. It's something about that piece that really locks it in. So,
well, good.
Yeah.
It's nice to find little techniques like that really work for you. Going back to kind of finalize it, reading it.
Right.
Well, nice job.
What was the Peterson's questions? What was that about? I don't understand.
So it was Thor Penderson. Is that what you're referring to?
Yeah. What were you saying, Adam, about some questions?
Yeah, so on Udemy, Thor Peterson has a bunch of practice questions that you can purchase. And so I purchased the hard ones and they seemed really hard. So then I purchased the easier to medium ones and that seemed a lot easier. So I think basically you buy them in batches of like maybe 250 questions. So you do like 125 in one hit, and then there's another exam of 125. And basically you just do it like an exam.
So I'm not familiar with him. I mean, I've read a lot of different Phil Peterson.
No, Thor Peterson. I'll put it in the chat.
Oh, Thor. Yes. He is on Udemy. Yes, he is. Okay, because I actually my company I work for has that, and I can do his difficult questions. But yeah, you're right.
Yeah, that's a great resource.
Yeah, I'm on the
April, when you said you were doing like 50 questions and you're going to move to 100 questions, like what does that mean?
So I do overall all 8 domains, just 50, right? But before I do 50, I've done 25 individual domains. So, okay. I feel like if I don't get 80 over that, then don't go further. Then I do 50, right? Because I'm trying to get my stamina up to like so that I can get more done because I run out of time. But now I'm getting 50 questions within the time period. So,
I see.
but I'm realizing that I'm okay. I'm comfortable more. The more I'm comfortable with the literature, the quicker I guess I can answer the question, which makes sense. So then I'm doing 50. But I'm doing 50 difficult questions, and then I'll move to 100, and then I'll just start doing the test exams, like 125 exams, and I'll just keep doing that. But right now, like 100, I would run out of time.
And
Great
yeah,
technique of building your stamina. That's a really good strategy. I had not heard someone speak so intentionally about building their stamina for test taking. That's a really good tactic.
Yeah, because I mean, I could, if I didn't have a time limit on it, I would just be doing 100 all the time. But it shuts me off at around 60 or 70 questions, and I'm like, oh my goodness. So I'm not really getting my true percentage of like what I pass, what I fail. Like I don't, because I have some missing questions.
Mhm.
So I said, okay, I'm gonna get the 50 under, and that's what I did with everything. I've worked myself up from 10 to 25 to 50 on all domains. So, and then I'll stick on like what, so today I'm gonna read domain 7 tonight after this, and then I'll do maybe like 25 questions on domain 7 and then do a whole nother 50 over and over. So like I do 54 times a day. So what am I doing? Like 200 questions?
Wow. You are
Right.
pushing
So
hard.
I'm not just
Well
doing, let me just clarify that. Yeah,
Well
let me clarify that. I do 50 in one setting, and then maybe half of 20 minutes later or half an hour, I do another 50. So I try and do 200 questions a day, but
wow.
in 50 increments. Does that make sense?
it does. Where are you getting all these questions from?
The Learns app. I'm looking at the Learns app. If you go on that,
Learns app. Okay.
yeah. And I'm going to switch up after I'm planning on switching up and looking in other areas and other question banks just to make sure I have a good flavor of different questions. So, I mean, that's just my plan. I don't know.
That's
We'll
a
find out if it works.
Are you coming across like taking the same questions, or are these like new questions you haven't answered before?
So that's interesting because there are new questions that pop up. I might see one, but then there's something else like this question popped up today where I'm like, really? It was kind of a question I should have known, but I wasn't sure which one. So yes, there are new questions. Oh, don't think that you're going to see the same. You may see one or two of the same, maybe three, maybe. But this bank is full of questions, so I'm not typically hitting the same questions over. And
nice.
then when you think you're hitting the same question, you think you can quick answer it. It was a change in that question. So no, it works. It works out. Like it's not the same ones. I do see a repeat, but nothing to make me feel confident that I'm repeating. I might see 3 out of 50.
That's really great to hear. That's really great to hear. For those of you who are new to the group this evening, Learns app is one of the more common recommendations that we hear from people who are passing. That and the Mike Chappell or Chappelle video series. That's another very popular one that gets referenced. So if you want to jot those down, I don't have the Mike Chappell link offhand or Chappell link, but
Earlier this week, I just signed up because I saw some people recommending that too, CC Cure. And actually, I like it. I'm liking it a lot. There's just a lot of questions. Yeah.
Would you mind? Do you have a link for that, Sandra? That you could
yeah,
put in the
sure.
chat for us?
Yeah, can you put it in there? Their question. Oh, I heard someone say something about CC Cure. Okay.
Excellent. Yeah. Well, let's see. I do see we have a couple of new people on the call. So Adam has spoken up. Adam, it's wonderful to have you here. Elaine, I believe you and I have met before in at least one other group. Really glad to have you here. If I have not met you, please forgive me. And then Sandra Patterson. I don't think I recognize your name as well. So really grateful to have you here. Forgive me if I mix your name up because we have another Sandra on the call too. So that's great to have you here.
No, thank you. And appreciate. I'm just new to these calls. I'm trying to do a career change into cybersecurity. So I'm just listening in, and getting all these tips is absolutely valuable information. I suppose it's just a lot to be reading, and the way I've been learning, not sure if it's the best approach, but I got recommended, there was a YouTube presenter, and I think it's Sean Harris. I think
Sean Harris.
Yeah. So I've just been listening on that, but I'm more of a practical person, so I'm not the one that can actually read a lot. I need examples because that's how I learn, visually and through examples, but it's just a lot of reading, so that's very difficult for me. So I suppose having that YouTube is something different where I can just perhaps listen in. But if there's other recommendations, or if I know I have to be reading, but there's books or things that people can recommend, I'm all ease.
There are so many wonderful resources, and you nailed it. A lot of times, especially in our field, we get a little burnt out on reading. If something is written down, it might even be out of date pretty quickly, and it's just a tedious way to study. We have so much to study. You called out that this is a broad exam, a mile wide and an inch deep. And video series definitely helps, especially if they include labs as well. And labs are not a concentration of the CISSP exam, but they're helpful for reinforcing concepts that might be unclear, getting that visual in your mind so that when it's on paper, it can make more sense. We'll do a couple, not labs, but we'll do some examples this evening just to help reinforce those concepts. But other people have great recommendations as well. If you haven't gotten involved in the school platform or school community, if you post a question out there with kind of, who else likes to learn this way? What resources have you found? I bet you'd get some pretty good responses out of that.
Okay, yeah, great. That's good to know.
Sandra, you mentioned you were looking to kind of break into cybersecurity. Where do you work right now, or what do you do right now, if you don't mind my asking?
Yeah, that's correct. So my background is in IT project management.
Yeah.
But I do have a bachelor in software engineering, which I never really utilized. So now I want to kind of do a bit of a change into cybersecurity, because it's been predominantly in software implementations for document content management. And so therefore, being a technical background, I can manage the project, also perform the technical executions. So I want to kind of like move into cybersecurity. I think that's what is actually starting to interest me.
Yeah, absolutely. Well, like you said, the technical background and project management, when you can merge those two together, you become very valuable. And if you add cybersecurity skill set on top of that, especially at the managerial level like this exam, you'll be positioning yourself very, very well.
Yeah, I think I don't have the advantage of knowing, I come from more software, so not the networking or infrastructure. So I have enough knowledge to have perhaps conversations and meetings, etc., but I don't have that in-depth knowledge.
Yeah.
So I don't know if that's a disadvantage for this whole cybersecurity, and not coming from that networking infrastructure background where I came from all the software side.
I'll tell this to you, and I've told this to a few people. We all have different expertises when we come into the exam. Sounds like software is a good focus for you. It's the opposite for me. It's a weakness in my background. I have more experience on the technical networking side of things. It's not necessarily an advantage or disadvantage, and here's why. If you have a lot of experience at the technician level, especially when we're talking about network system level security, it's very easy to get sucked into technician level thinking versus a CISSP wants us to think at managerial level thinking. So sometimes coming into a domain that is brand new, you can actually outperform technicians on the exam just because you're training yourself from scratch to think like a CISSP versus someone who's a technician might have great habits, but those habits might be counter to what's expected of them on the exam. So I wouldn't look at it as a bad or a good thing. You're coming in blind, which is kind of fun, I think. I think that's fun. It's more challenging, but...
I remember that when I did the exam. I'm coming in blind.
Yeah, I remember. This is fun. Okay, so we'll go ahead and get started here. With, so thank you guys for introducing yourself. I really appreciate it. I know we had a couple other people on the call here. So just to have a brief introduction, my name is Josh. I am CISSP certified. I have my master's degree in cybersecurity and information assurance and currently teach at a university. But I love this group so much that I'm quitting my university job because I just want to spend more time with you guys. And there's no joke in that. I just really enjoy the people that I get to be around in this community. And it's so much fun seeing how many people are passing. So thank you guys. I'm not an instructor here. I am also a member of the study group and more of just a facilitator in this role. So like has already been called out, I do not know everything. So if you have a software connection, we can ask Sandra or someone else in this call, but I also have a question list next to me. So just because I don't know it all, please ask the question anyways. I'd rather us address it here together than it be unaddressed when you're sitting for your exam. So we've talked about some challenges and successes. A couple people mentioned they had study dates coming up in the next month or two, which is really great. We have one or two other people that want to share some challenges or successes before we move on to what we have to cover today. Also, there is a poll launched, an icebreaker poll. For those of you who are new, we will be using the poll functionality of Google Meet to go through some practice questions today. So to find that, you'll look for the activities box. It's a couple of shapes in the bottom right-hand corner of your Google Meet screen. If you click on that, you can navigate into polls and you'll see that I have an icebreaker poll launched. So if you go ahead and answer that, I just want you to get comfortable with the poll functionality before we move into practice questions, which is what we have our concentration on today. Let me see. I don't think I saw Sarah or Sam join our Thursday sessions. But if you guys are not aware, you can send me your practice questions directly. And I love, love, love getting them. I'm going to put a link in the chat here. You can use the not so pretty looking form, but if you can use the form and your practice questions will come directly to me. So if you have one that's especially difficult, you're not really sure why the answer is what it is, or if you just think it's really challenging and want other people get to enjoy it, please use the link that I am putting in the chat right now. So bookmark that, do whatever you need to do. And today, our practice questions are going to focus mostly around domain 4, communication and network security. It's just perfect timing that Sandra had mentioned that was kind of maybe a weakness of hers that she's wanted to study. So don't be intimidated by any of this. Just ask lots of questions. We're going through practice questions focused equally on the topics that we need to study and also how do we think well for the exam. So, okay. Boy, we got a pretty split vote for studying approaches. That's kind of cool to see. A variety there. Nice. So before I go to the next slide, which is our first practice question, just to orient you to the process, I'll have a timer on my phone. We're going to do 50 seconds for each question. When I hit to the next slide, the practice question will come up. You'll just take that 50 seconds to yourself to read through it and select an answer. You'll put your answer into the poll. So it'll be a lot easier to read on the slide, but when you're ready to answer, go ahead into the poll and you'll see the option there that you can click. Once we're done with that, we'll come back and we'll discuss the answers and just unpack it to the level we need to. Please don't put any answers in the chat, just so other people have an opportunity to respond blind. So, any questions before we kick things off together?
Sorry, Josh, can you just repeat? I think I missed it. Where did you do you go for the polling?
Yes, good. Thank you for asking. The polling is, so if you look on the bottom, at least for me, in the bottom of my Google Meet screen are all the different buttons and options. There's a set of icons that looks like some shapes, and it's the activities pane. If you click into the activities, you should then see polls as one of the options.
Yeah, perfect. Thank you.
Absolutely. Excellent. Okay. Any other questions? All right. If we have any, we can go through them after question 1. Here we go. Oh, I spent a lot of time on this question. This is a good one. Okay, a few more seconds left. Get your answers into the poll. All right. There we go. Good deal. Boy, this is kind of the split I figured we would see. So I'll show you guys there. We got mostly a split vote between router and bridge. And oh my gosh, I'm going to give you the answer right off the bat. It is router, but this is a great example of how the CISSP exam wants to mess with you. You could justify with pretty good integrity every single one of these options, and you wouldn't be incorrect. You wouldn't be incorrect. So let's walk through these in order. But first, I want to call out that some of what we're going to talk about is related to the 7-layer OSI model. And I'll put a link in the chat here in just a moment that has some just additional resources that you can go to study. I will call out if there's things that maybe are not worth your time that I share with you as far as studying for the exam. This is one of the ones I would tell you to study. Knowing your layers of the OSI model and how they translate to different protocols or devices will be important, and it's very likely to be included on multiple questions throughout your exam. It's just an important concept for us as IT professionals as well to understand the model. So having that model and the layers in mind helps to answer this question. So who's brave and wants to play the keyword game with me and pick out our keywords from this question that we want to worry about?
I'd say control the traffic is...
Control the traffic. Absolutely, Adam. That's exactly right. That's a really important piece of information. Who's got another one that stands out?
2 networks.
Yes, Sandra, 2 networks. And let me see if there's any other. Those are really the 2 that we need to worry about. But with those 2 pieces of information, we can get a solid answer here. So we're going to walk through one at a time. I'm going to tell you why switch could be the correct answer, and then why it's not, and we'll just go through it that way here. So first, which layer of the OSI model does a switch live at?
2.
Who's got?
2.
Yeah, 2, absolutely. What is layer 2? Refresh my memory. I have such a terrible memory.
Data link.
Yeah, data link layer, exactly right. So this sits right above the physical layer. Mostly we're concerned with MAC addresses, the physical address for devices that are sitting on a network, and they're interconnected through layer 1, that physical. So the data link, that's exactly right. So we've got a switch. That's going to route traffic at layer 2. Are there switches that operate at layer 3, yes or no?
Yes.
Yes.
Okay, yeah, absolutely, absolutely. So a switch with no other information given, if it were just a layer 2 switch, yeah, this could work. We want to connect 2 networks. That's absolutely a way we could connect 2 networks. We can't do layer 3 unless it says layer 3. So a switch isn't necessarily wrong. It just might not be the best piece of network equipment to accomplish this. So if you put switch, you're not incorrect, but there's a better option coming. Okay, a bridge. This one really got me, because the only thing that doesn't really fit with this, Adam called out for us, is we need to control the traffic. What a bridge does is exactly what it says in this first set of keywords. It connects 2 networks and allows them to communicate together. Typically, a bridge just communicates a handful of networks, unlike a switch, which might help connect multiple networks. A bridge is a little more specific in its function of connecting fewer, just like a bridge in real life. So the reason it's not a bridge is because a bridge is also layer 2. So we don't get that control over network traffic necessarily, because we're communicating between 2 networks. Okay, what about a gateway? Who can tell me where a gateway fits into that? None of you picked that as an answer. Why? Someone tell me why you didn't pick gateway.
The gateway is sort of, it's like a door opener.
Yeah.
It's like a way to get in. It's not really a connector.
That's a great way to describe that, Elaine. Thank you. So we could have a gateway, which first is a term, not a device necessarily. A router can be a gateway, but it's not always a gateway. It kind of acts like that, but we won't necessarily call all routers gateways. All gateways pretty much are going to be routers of some point. So there is a subset of terminology that's going on here. None of you fell for that trick here, so we're not going to go any deeper in there. A router, The key thing here is that it has the ability to help control the traffic as well. We can set up rules, we can set up routing rules, and it can absolutely help between two networks, a lot more networks than just that. So this is a tricky question because if you get in a rush, any single one of these could look like the correct answer, but we're looking for the best. And focusing on our keywords helps us to avoid going down the list and saying, oh, a bridge, that would do it. And you're not wrong, but you're so close. So does anyone have questions on this before we move forward? We have some more interesting stuff that we're going to get to, but I wanted to just kind of give you a peek. We're going to be chatting about the OSI model during this.
Yeah, Josh, it's a good question. Yeah, I picked router, but it was kind of a toss-up between the switch and the router.
Yeah, it should be.
When it says control traffic, you can control traffic on the switch as well.
You can, yes, absolutely. Layer 2 traffic, unless it's a layer.
Correct, but it didn't specify what type of traffic.
And so Paul is bringing up exactly why I marked this as a challenge question, because boy, if you look at the definition of a bridge, it fits into this so perfectly, and it doesn't necessarily say control the layer 3 traffic. We kind of are making an assumption that when we're connecting to networks, we have to start bringing in that third layer of the OSI model. So there's a little bit of a hidden assumption there, but you're absolutely right in that it could be very confusing there. So Ravanan, did you have something to call it that might help us unpack this?
Yeah, I mean, my understanding is switch is between only connecting the internal devices, right? If you want to connect all the devices in your LAN, that's where you use for switch. And switch is not for connecting networks.
Yeah, that's a great point. Switches we won't use to connect networks necessarily, unless we're working on that layer 3. We can help to route traffic a little bit, but only at the layer 2 level. And a bridge is much the same, just has more of that specific functionality of going between two networks. And they kind of throw that in as a confusion answer. But there is kind of an inference here that we want to control layer 3 traffic. The controls that we get over layer 2 are kind of minimal. We can do whitelisting and blacklisting of MAC addresses, but when we get into IP routing and using networks like subnet masks, the granularity of control that we have over network traffic becomes more substantial, more robust. So I hope that answers your question, Paul, but I had that exact same.
Yeah, somewhat. I just wanted to point out, that it's a good question. So.
Yeah, it is. And thank you to Sarah, who is not on this call. She's one of our moderators in the community. You'll see SM as her initials. So she's not here, but she submits good questions. Okay, let's get ready for question 2. Get my timer up. Okay, go for it. Okay, nicely done. Get a couple more seconds to answer. So I'm going to put something in the chat that I'll reference, and you can bookmark it if you want. Okay, ooh, very split answer. Excellent. I like to see that. All right. Anyone feeling real confidence in their answer? And you know what? I'm going to pause actually here because I want to just acknowledge that this is the sort of question I would not recommend necessarily studying for. There's a couple rules of thumb that can help you in the exam, but I wouldn't spend a substantial amount of time memorizing bits or key lengths or things like that. Have the essentials, the basics of our profession, the most common, maybe have those in your head, or at least the baseline of what is a good number of bits for this type of encryption. But this is talking about, this is what we currently use for RSA. This is an encryption algorithm. Rivest, it's the guys' names. I can't remember their names offhand who invented this encryption algorithm. But you don't memorize a table for how do I get from here, this RSA encryption, to this ECC key length. ECC is elliptical curve cryptography. We're not going to go into that tonight. I put a video link in the chat that you can go watch that kind of explains that a little bit. ECC is very common for encryption, especially on mobile devices, because it uses less processing power, which is why we have this question. What ECC key length, much shorter, is going to be comparable to RSA? We don't have to use as strong of a key because the way the algorithm works is stronger in general. So the rule of thumb, I put in the chat, is RSA to ECC, it's about 1/8 to 1/10 the size. So we'll take this number. Easiest way is just to drop the last digit on here. Just drop it. You're dividing by 10 is what you're doing. So 307, and look for the closest option that fits, which is 256 bits, our correct answer here. That's the rule of thumb. 1/12 to 1/8 the size of the RSA key bit. If you have that in mind, you don't need to memorize the table. If they give you the key length of RSA, you know, okay, Josh said to take off the last digit and then look for the closest answer. There you go. 9 times out of 10 should get you to the right place. Yeah, Sandra, go ahead.
This is what you're saying for ECC?
Yes. So
Okay.
to go from RSA to ECC, if you want to get the sense of the comparable key lengths. So let's just take an example. I have a mobile device, and right now I'm using 3072-bit RSA encryption. It's pretty strong, nice, but it's taking a lot of processing power for my phone to take a key length that's long, that's huge. So I'm going to make the change to elliptical curve cryptography. It's can have the same strength, the same security, with a much shorter key length. How much shorter? About 1/10, something along those lines. So now I have much less, or a much shorter key length that I have to work for, less processing power for my mobile device without sacrificing the security. So pretty powerful technology. I would encourage you to watch the video that's in the chat because it is very interesting. I would love to do a session on that sometime, but it's one of the more specific topics that I just recommend studying on your own.
Cool, thanks. Because I did remember one of the things when I was reading about this, I did know that it uses less computing power and then it's shorter encryption keys, but I didn't know this part. So that's why I guessed.
Yeah, the rule of thumb is exactly that. It's a rule of thumb. It's not absolute. It's not going to give you the exact answer, but it's going to put you in the ballpark of the correct answer. And for the most part, there's only going to be one answer, maybe two, in which case, was it worth the time to study the entire table? I don't know. Elaine, you had a question? First of all, am I pronouncing your name correctly, Elaine?
I have, so do we round down or do we round? Because I'm looking at this and you're saying, you know, it's 256 and your explanation completely explained that well. But what if someone would go, you know, 512?
Yeah, if they wanted to put 512, and that's a reasonable assumption. So let me copy this and put it in the chat as well. This is the actual math for this of the 1/12 versus 1/8. So if you were to do this, you would see the very lowest it would be is 256, and the upper boundary on that, if we only were to divide it by 8 in that rule of thumb, doesn't quite get us up to that 500-bit mark. So if we do that, then we're going to fall pretty closely within the range of the correct answer there. But it's kind of question specific. There might be question options here that do put 2 within the same possible range. At that point, you are kind of guessing or making an educated guess. So it's not perfect, but it'll be a quick way to find that answer.
Okay, cool, thanks.
Yeah, absolutely. Sandra Patterson, yes.
Just on what you just said, if there are 2 numbers within that range, what do you do?
That's a good question. And my honest answer is pray that there are not 2 answers in the same range. I would say it's fairly unlikely that that would be the case. Not impossible for sure, but for the most part, The test writers are going to spread them out the way they did here, the way we would see them in their natural habitat. And they're spread far enough out that with our small range, typically we'll just hit one of the possible answers. But not always the case in that situation. Unfortunately, it's kind of a guess or educated guess.
So just to recap, are you saying you look for, effectively, you're going to look for a range between 256 to 384?
Exactly. That's exactly right. Mm-hmm. And if I were truly just doing this on the exam, then I would just drop this last digit and look for the closest answer. So I would just, you're effectively dividing by 10. So I would say, okay, 307 bits is the closest to what it's going to look like for ECC. That's pretty darn close. I'll go with that. That's how I would answer it in a question. Spend a few seconds and then I can move on there. This one is, unless you want to memorize the table, the rule of thumb is kind of the way to go, because the other option is truly just memorization, unfortunately, which is always an option, but not the fun one when we're doing this much studying.
No, I'll memorize your rule of thumb.
That's a little easier. Just drop the last digit and look for what's closest.
Perfect.
Just on that point, so the CISSP exam writers, like, they're not necessarily out to trick us, right? Like, they're just trying to like gauge our knowledge.
I think that's a trick, yes.
Oh, damn it.
Yeah.
That's a shame.
So did you have a kind of a follow-up question on that though, Adam?
No, I just wanted to clarify, like, are they trying to trick us or not?
Yes, they are intentionally trying to trick you. We typically, I don't think I do today, typically we have some bonus questions at the end where we try to manipulate the way that they trick us in the exam, where we just look at the answers. Actually, we don't even look at the question, we just look at the answers, and we're able to decipher how they tried to trick us. And a lot of times we can get the answer without even the question. It's pretty amazing. So I don't think we have any bonus questions this time, but if you've watched in the recordings, you maybe have seen how we test that out, because they are trying to trick us. So we try and use that mentality of, how did they try and trick me? If I know that, maybe I can figure out the right answer or avoid the trick answer.
Awesome, thank you.
Yeah, fortunately, they are going to try and trick you. All right, let's do question 3. Get yourself ready here. All right, go ahead. Okay, a few more seconds. All right. I'm going to put a link in the chat that might be helpful. This is from CBT Nuggets. I don't know if you guys have come across them. Nice training website. I don't think I've ever been a member, but they have a lot of good resources. So let me get this poll ended so you guys can see it. Ooh, nice split poll. Okay. Let's see what our answer is. N. Okay. Let's pause again. These are not things I have memorized today. I would guess, unless you have studied these recently, they're probably not things that you have necessarily memorized or you did in the past for a certification exam. These are not part of our everyday jobs, but they are going to be important to know on the exam. This is one of the topics that's having a sense of the different wireless standards will be helpful for you. So take a look through that link. It has a chart that is helpful to understand the different ranges and also what those ranges do. If you want to be able to go through walls better, which do you want to use, 2.4 or 5 gigahertz? If you want to communicate longer distances, should we use 4 or 2.4 or 5? So I'll encourage you to go through that and use that as a tool. Unfortunately, there is just some memorization that takes place on that. They have, if I remember correctly, a chronological breakdown. So it tells you, here's the first 802 standard that came out. Here's what it used. Here are deficiencies. And then the next one. I find those chronological breakdowns helpful because you can get a sense of, Okay, this one was deprecated, so now I understand a piece of that one. This aspect of this was insecure. Okay, well, it must be secure in its replacement. So if you can start to get a sense of that, it really helps with these. But otherwise, they do just require some memorization, unfortunately. So we are going to go into that. I'll encourage you just to go through that resource. We can have another conversation about that because next week we're also going to continue with domain 4 questions. So Ramadan, yeah, go ahead.
It says G is also 2.4 there in that list.
Yeah, it will also support 2.4. Yeah, yeah. 802.11, I think does. Let me actually open up my. I'll open up the same thing here. We'll just go look at it. So here's that chronological aspect. 802.11a. Okay, not super fast, only 5 gig. What were our other options? We had G here, sports 2.4. What was our correct answer? I don't have my N. Let's go find N. Where's N? There we go. N. So it can support either one. And the difference here is that it's quite a lot faster. That's the main difference that I think they were looking for in the question here. Fast as possible and limited to that range. So even though it supports both ranges, which is great, it's also faster than the one that only supports the one. So it's challenging because you would have to know that. You would have to know, okay, N does support 5, but is it faster? I don't know. So this is a challenging question because it does just require some memorization, unfortunately. So I would encourage you to use the resources that CBT Nuggets has within that.
I mean, we can't take that chart with us in the exam.
Well, you've heard my brain dump idea, haven't you, Paul? Haven't I? Well, just because you guys are all on the call here.
Yeah.
The day of your exam, the day before and the day of, review your acronyms. And then right before the exam, the hours preceding, have a cheat sheet in front of you that has your most important information that is the hardest for you to memorize or retain. Or the things that just take you a long time to remember, like subnetting. It's nice to maybe have a quick subnetting chart sometimes. As soon as you get into the exam, take out your whiteboard or blank paper or whatever they give you and do a brain dump. You're not cheating. You're just making yourself a cheat sheet real quick from memory. And it just so happens you maybe just memorize it about 2 minutes earlier in the lobby. And that's okay. So
good tip.
Yeah, that helps. Okay.
Because all I remembered, I picked AC, the last one, because I remember that's the fastest.
Yeah.
So
let's go look.
It doesn't support 2.4 gigahertz.
AC. Yeah, there we go. Yep, exactly right. It's almost twice as fast, but only supports 1 bandwidth. So yeah, that's exactly right. It would be difficult to answer that question if you didn't have a chart like this somewhat memorized, or didn't at least. I'll give you another exam tip that you can have. If you don't want to memorize, I mean, you wouldn't really memorize any of that. You probably wouldn't start memorizing until A. You could also choose to memorize the 2 or 3 that you think are most important or most relevant, or just the easiest to memorize. So you have a portion memorized, and when you come to an exam question, either you'll know it, in which case it likely falls into the ones that you did memorize, or you don't. And you can try and use a process of elimination of saying, well, I know it's not AC because it doesn't support that. I don't know what else only supports 2.4, but I do know what only supports 5, so I can at least cross one off my list. You don't have to memorize everything. You can just choose to memorize little bits and pieces.
It does look like the later letters are faster ones.
Yes, absolutely. As we go through this progression here, absolutely, we start to get, you can see, exponentially faster. It's really incredible. I mean, here we're only at 54 megabits per second. Here we're screaming. Yeah. Cool. Let's get to another question here. Get yourself ready. There we go. Go ahead. Okay, a couple more seconds. Get your answers in. All righty. Nice, nice. Majority have picked it up there. DNS poisoning. DNS poisoning. Okay. Let's start from the basics. What does DNS stand for? Who's got that for me?
Domain name.
Domain
service.
name system.
Domain name service. Excellent. What about NS lookup? What is the NS on that? This is
Is
the
it
command.
name something? Name.
Yeah. Name server lookup. Yep, absolutely. Name server lookup. So we're going to try and resolve the name server from an IP address. Exactly. So this is how, if we, well, we'll get into that. We'll get into that. There is a link in the chat to something from Cloudflare that we're just going to walk briefly through. Oh, I keep giving you guys sneak peeks. Okay. We're going to walk through this just very briefly. I would love for you guys to go through this on your own time if you would like. But this is more related to different types of attacks. Attacks do absolutely get referenced on the CISSP exam, but I really want you to understand the protocols and services that are going on behind the scenes that make those attacks possible and why they do. So there's a couple of nice graphics here. So domain name service caching. Keep this stuff in mind because we're going to be talking about caching in a little bit when we talk about address resolution protocol, which is kind of in the same ballpark of what DNS is helping us to do. All right. So we have an authoritative name server. What is an authoritative name server? Someone give me an example of what I'm talking about there. What could this device potentially be?
The DNS server?
Yeah, it could be the DNS server. That's exactly right. These devices could potentially, I guess I can't highlight it like I normally do. We have the DNS server. The authoritative name server is a bigger scale of what the DNS server is. Exactly. So we have our DNS server. This could be, let's pretend this is local. We're in Josh's office. I have my own DNS server. Why? Because I host my own stuff. I want to map domain names with my IPs if I want to. So that I can just type in a domain and automatically have it go, my web browser navigate to that proper domain and proper IP without me having to memorize the IP. That's what this is, what's going on in the background. We're saying I have an IP or I have a domain name, but I don't know what IP to go to. That's what domain name service is doing. Where does it get its information? If we're not just talking locally, it goes to a DNS server, but a big DNS server, an authoritative DNS server, exactly like Saravanan called out for us. These are the big boys. We've talked a lot about certificate authorities. This is kind of similar, a little bit similar, but we're actually, this is where we have a domain that we have established and we have an IP address that is hosting our domain or responsible for resolving that. So what happens, so this actually was a question I got in an interview once. If you're user one and you want to go to google.com, what happens? Well, behind the scenes, you're going to send a request to your DNS server. That might just be your router and then passes that up to your, like Saravanan had called out. You'll have a DNS server that's configured for you. I want to take the time to do that. We're not going to take the, you can configure your own name servers. If you go into your IP configuration settings, you can set this manually if you want to. Google's domain name server is 8.8.8.8. Its secondary one is 8.8.4.4. So if you do that, if you use that, then you'll be, every time you're looking up some service, you're essentially asking Google to go find that service for you. If you use the IP address of my DNS server, you're going to ask just this tiny little local thing. Hey, do you know where this resource is in the world? And it's going to have no idea because it's localized. And so that's the process for resolving that. We say, what's the IP for google.com? If the DNS server doesn't know, then it will go talk to an authoritative name server. Why would a DNS server already know the IP address and be able to pass it back to me without looking at the authoritative name server, without talking to anyone else? What would be going on behind the scenes to let the DNS server just know that information? Who's got some ideas?
It wouldn't be.
Caching.
Caching, that's exactly right. Thank you. The DNS server, as it's performing these resolutions, as it's resolving domain names to IP addresses, it maintains a cache. It has a table of IP address to domain name, IP address to domain name. So when user one reaches out again for google.com, there's lower latency. It just has the response cached and ready to go. So what do you suppose DNS poisoning does? Oh man, let's scroll down here. Okay, well, there's the cached response. We just go directly to the DNS server. I didn't realize they had that on there for us. Okay. So we're not going to go through the poisoning. Let's go through the cache being poisoned. Oops, I just lost my screen. There we go. So the user is going to reach out to the DNS server as it normally would, asking, hey, I'm trying to get to google.com. What's the IP address? The DNS server, though, is not going to have the correct IP address in its cache. Its cache is going to have been poisoned by our attacker. There's lots of different ways that this can happen here. First of all, you can manually configure this. Your workstation, at least if you're on a Windows device, I don't know what the terminology would be for a Mac, you have something called a hosts file. You can go into that file and manually put these in for your workstation. If someone got access to your workstation, they could go just edit that file and they would have poisoned your local cache. In that case, your user workstation wouldn't even go to the DNS server. It would say, I already know google.com. It's in my hosts file. I'm just going to go straight there. Well, we could poison that hosts file. That's a fun lab to do, by the way, because you can just do it really quickly on your own. We could poison the cache of the DNS server. Now, this could be through technical exploit. That's a common way. There's some other ways that we could do cache poisoning as well. But the bottom line is we are trusting the cache of our DNS server. We're trusting the cache on our own workstations. And if those have been tampered with, if they've been poisoned, is the term here, then we don't actually know what resource we're going to get past. You can see it's passing us an IP, but that IP could be anything if the cache has been poisoned. So I don't think there was anything else on this page I wanted to go through. So go check out this site if you want to read more into that. It's a really interesting process. Yeah, Paul, go ahead.
Yeah, Josh, so I guess from a networking standpoint, a good way to check that is if you have like other users that's experiencing the same, that can't get to that same website.
As far as
Maybe.
Being able to prevent this sort of attack, is that what you're asking?
No, like if, you know, to help differentiate whether it's DNS poisoning or something else.
Yeah, if you were trying to distinguish what type of an attack it were, you could definitely direct.
Yeah, not to cut you off, because if my coworker is able to get to google.com and I'm not able to, then I don't think it's DNS poisoning, right?
Yeah, you wouldn't necessarily jump to that as the reason. Yeah, I'm not confident I'm answering your question correctly, though, Paul. So feel free to ask it again if it's.
Yeah, I'm not sure I'm asking it right either. So.
Well, here, tell you what, I'm going
That's all right.
to call here and think about your question and ask it again. Okay.
Yeah, no problem. We can move on.
Cool. Adam, yeah, what you got, buddy?
I was just curious, the authoritative server, like what kind of company would run that? Is that Google or is that like your ISP?
Google could absolutely be the case. Okay, I am going to show how this is because I just think it's interesting.
Go
ahead.
AWS do it?
Yeah, AWS would absolutely do it. When I provision a domain through a service like AWS or GoDaddy, then we have our DNS records that we get access to.
Mm-hmm.
We can go modify those records to map our names, our domain name, with different types of IP addresses and resources that we have. So an authoritative name server is global. That would be like Google has name servers that they maintain. Someone called out that we could have internal domain servers that help resolve things internally. So if you have an organization internally, you may host certain services. They don't need to be publicly accessible. We don't even want them to be publicly accessible. So we might just have that on our local domain server. It wouldn't be authoritative to anyone else, only if you're on this particular domain. Does that answer your question there, Adam?
Yes, very much so. Thank
Okay, cool. Yeah, excellent. Someone else had their hand raised. I missed
It
who it
was me. It was me,
Yeah.
Josh. So I maintain records for DNS records for my.
Ooh, please
So
share a little bit.
So I have go into a site, a database, and I go ahead and what I do is I put in the name of the record, whatever type of record it is, the time to live, and I also put in either I do a CNAME, a record, or I'll do a text record. And I'll put in either the IP address or the route it's going to go to, it's going to resolve to. And then and also once I can do that, then we also do a AWS Route 53. So we put it in a database, the AWS database. That way it can resolve there too. Like it can.
Yeah.
So.
And that brought up a lot of really good terminology for this. And first of all, she mentioned Route 53 as Amazon's specific service that helps implement this domain name service. She also brought up a lot of great terminology as far as the DNS records. Yeah, we have an authoritative server on the call. You're right, Adam. Let me go to, this is a tool that I use quite often for just different types of work, but we can scan domains to try and get a sense of what records they have. So let's look up school.com. That's the platform we work with. So what we're scanning for is, how is the internet configured to discover and navigate this domain? Well, school is not particularly well secured. It's not super surprising. This is not an uncommon score. We can see we start to have some different frameworks and protocols that are being brought into the mix here. This is all under the umbrella of domain name service, but we can look at the individual records here. So we can see that Google.com, we can see SendGrid, Scout Mail looks like. These are different services that the school platform has configured securely or insecurely to use their domain name or work with their IP addresses that they own. So, and that brought up some great concepts. We're not going to get any deeper in there. I am going to put this link in the chat just because I think it's a lot of fun. You'll be surprised how many Fortune 500 companies score really poorly on this. I have only scanned a couple of companies in my entire career that have passed this with flying colors.
What number would a pass be?
Let's see. So they usually have another option here called BIMI, B-I-M-I, brand indicators, messaging, something or other. I don't typically include that. That's usually more for like trademarks and such, and it usually does populate as part of a score. I would say an 8 out of 10 is a good score. You should absolutely have SPF configured. You should absolutely have DKIM configured, and you should be working consistently on your DMARC. SPF and DKIM are your standards, and these help you identify, okay. Actually, I'll touch on DMARC because just a little bit. I don't want to get too off track, but I do find this really interesting, and I've worked a lot on trying to get companies to migrate towards this. All right, SendGrid. SendGrid, I think it must be some sort of a marketing thing, right? SendGrid, I'm guessing it's a marketing, yeah, email marketing campaigns, exactly. So if I have a domain, joshbotz.com, and I have an email server or an email through Google. So I use Google Workspace or something like that to host my Josh Botz email. Well, what if I want to let SendGrid send emails on behalf of joshbotz.com? Well, this is where we can configure that. Without DMARC configured properly, any server can send out mail claiming to be you. DMARC says if it's not from this specific IP address, then it's denied. Or it's, well, not necessarily denied. Here's what they have. It's set to none, which means nothing actually happens. We can send email from the school.com platform all day, and nothing really happens. They could quarantine us if they change their configuration policy, or they could reject us. Typically, this happens in a process because companies usually have a handful of platforms that send mail on their behalf. And if you set this to quarantine or reject, any mail that's coming from those servers to your clients is going to get stopped. It's going to get quarantined. So really powerful configurations to prevent email spoofing and email business or business email compromise, which just from my professional experience are some of the most common attacks that I am seeing and seeing succeed is business email compromise. Really easy one to bring to your employer. Really easy one to bring to your employer, especially if you're looking to break into cybersecurity. Do a quick scan, look at these, and get a sense of what it would take to get from a 4 to an 8. You can bring a plan to your boss and say, hey, I noticed this. This is what risks this is bringing to us. If we make these handful of configuration changes, I think we'll be in a much better position. Talk about a good way to break into cybersecurity. Okay, I got off on a tangent. That's good stuff. Okay, get ready here. Well, first of all, does anyone have more questions before I move on? I tend to get excited. Yeah, Florence, I'd love to hear from you.
Josh, so what's the exact difference between DNS spoofing and poisoning? It's kind of confusing.
Yes. Let me see if they address that in here. Oops. Because they're the different, I mean, it's, you can see right here, there's a little bit
the same thing. So
yeah,
they
absolutely.
talk about poisoning and then they twist the word as spoofing. So ideally it's kind of same.
They are, it's very confusing because they're kind of subsets from each other a little bit. And someone feel free to chime in if you have a different answer for me on this. When we are, let's go back to, did I already exit out of that? I guess I exited out of that. Let me find the link again. Okay, so, oh, I was already on that page. Let's go to this here, because this kind of shows us our full process. It doesn't show us the attacker. It doesn't necessarily show the cache, but we can understand all of these have caches. Spoofing, I don't know if I care for that specific terminology here, but it isn't inaccurate as a subset of poisoning. The reason we use poisoning is because we're going to think of like poisoning a water well. You put something bad in and it kind of contaminates the whole batch. What we're trying to do as attackers to this DNS service is poison it. We're trying to put some fraudulent information in, some inaccurate information, so that we can have our data be the one that's used by a client. Spoofing takes us a little bit differently, where we are now trying to mimic a domain ourselves. So we're going to take it a little bit of a step further in that. So we poison the DNS server. Our user reaches out. What's the IP address for example.com? Well, we've poisoned the cache, so they're going to get a response back of an IP. They're going to navigate to that IP, or their workstation is going to, using this combination of information, and they're going to get presented a web page. DNS spoofing is where we could start to take over the application layer of that. So it goes a little bit deeper as far as the attack. Poisoning refers specifically to what's going on right here. Spoofing can be a little bit more of a broad term for what's going on in general here. That's not a strong answer. I just need to acknowledge that right off the bat here. Poisoning is the correct term. Spoofing is a bit too broad for what we're looking at here. So I hope that helps bring a little bit of clarity, but it's not perfect. Yeah, Sandra Patterson.
Yeah, sorry. Just on what you've said, I get the whole poisoning, and I like the analogy you gave of that dam, and you put something in to contaminate it. But when you said the spoofing, you said it's more the application. I think you said. I'm not really sure I'm understanding this whole spoofing. I get poisoning, that makes sense, but that's when you say it tries to intimidate. Did you say intimidate? No. What was the word that you said? It mimics. Sorry, it mimics.
Yeah. So this is.
So what would I be as a user? What would I be? I get the whole poisoning as a user. It will then that IP will take me to an incorrect site because it's got the wrong IP address because of the poison. But when it's spoofing, what would I see? What would be different from the user's perspective? Is my answer my question clear?
It does. Yes, your question is clear. So pause me if I'm not making sense here, because this is one of the challenges of being the facilitator who's learning how to teach. So if I don't answer your question well here, Sandra, what I'm going to do is just write it down so that next week we can readdress it and make sure I have a good answer prepared. So DNS spoofing. Let's talk about that from a user experience perspective. We have been poisoned, but what actually happens when we're this first user? Okay, what's the IP address for google.com? It's going to send us back a poisoned IP address. We don't actually see that IP address as users. It's happening in the background, but what we see on this browser is whatever the attacker put at this IP address. That's where one aspect of this spoofing can come in, is we're seeing something, and I use the word application, and there's an application layer of the OSI model, which is really where we're starting to interface with the program. So the user is going to see on their browser some page that has been spoofed. The attacker has poisoned the DNS server with fraudulent information, and now when we're trying to access the correct site, we're seeing a spoofed site.
So sorry, just to interrupt. So as poisoning, I get it if it's got the wrong IP address for Google, for example, right? Just bear with me. As opposed to take me to google.com, it'll take me to joeblocks.com because that was a poison. But as spoofing, are you saying it's going to take me to a mimic version of Google and it's giving me a fraudulent interface to what I believe as a user thinking it's Google, but it's not. And that's how I can then, at that point, if it's trying to get, I don't know, bank details or something, I then hand over those such
That's
information.
exactly.
Is that what you're saying? So as a user, it may not necessarily be so obvious because it's a mimic, but it's just a way for them to attack you. Whereas poisoning is just going to take you to something entirely different. Is that what you're saying?
Yeah, and that's a good explanation. That is. The poisoning is the specific attack that's going on behind the scenes that we wouldn't necessarily see. Spoofing is what we as a user would experience. They spoofed this page for me. They mimicked this page. DNS spoofing can also be a couple of different things, which is why I'm hesitant to jump too deep into it, because we've got cloudflare.com. What if I did cloudflare.com? Well, this is typo squatting or domain squatting. So it's a little bit different, but this is also a type of spoofing that might take place, is actually in the way you would view the domain. So Ravanan, you've always got a great answer for us, man. I'd love to hear from you.
No, I'm trying to clarify this. I think a DNS spoofing is kind of real time. So the attacker tried to intercept the communication and then modify the IPs. But the DNS cache is going to change directly in your cache. So there's a difference between the spoofing and the cache.
That's a great call out. That's a really wonderful call out. Thank you, Sravanan. So let me just repeat what he said. We have a cache on the DNS server. When we're talking about DNS poisoning, we're absolutely going to poison the cache. That's our main attack point. In DNS spoofing in general, we're not necessarily concerned about the cache. We might be using cache poisoning or DNS poisoning as one of our ways to do this exploit, but there's other ways that domain names could be spoofed that don't involve caching in this. So again, spoofing is a little bit more of a broad term for how we might experience that, whereas DNS poisoning is a specific type of an attack that you could use potentially as a part of a broader spoofing attack. So I hope that brings a little bit of clarity to that. I know it's not perfectly clear there.
No, thank you. Appreciate it.
Yeah, absolutely. Good, really good questions. Really, really good questions. Okay, and really good questions, because we're going to actually repeat this almost a little bit with some other protocols coming up here shortly. So get yourself ready. We're going to do another question here. All right, go ahead and start.
that could potentially be a tricky one, but you have to know it.
Yeah.
It does feel like a trick. Do you start at the top or the bottom?
Okay. Let me get back to the polls. You get a couple more seconds to answer while I find it. All right. Ooh, okay. We got a little split answer here. Correct answer is layer 2. What is ARP? What does that stand for? Sravana, you still, I don't know if you still had your hand raised from the last question or if you're, but go right ahead.
Address resolution protocol.
Yeah.
Yes, address resolution protocol. What about RARP with the R in front?
Reverse.
Reverse. Excellent. So what does ARP do? What does ARP do? And while someone is throwing out some answers, I'm going to grab a couple of links to put in the chat for us. Actually, a lot of links.
Well, ARP resolves the IP address to the MAC address, and reverse does the opposite.
Yeah, exactly. Paul called it out for us perfectly. When we are using ARP, we're saying, I know an IP address, but I don't have a MAC address. I know something at layer 3, but I don't have something I need at layer 2. RARP, reverse address resolution protocol, works the reverse, and it's pretty deprecated, so you won't really get a lot of questions about RARP. It would be unlikely, I would say, other than as kind of trick answers. It's saying I have a MAC address, but I need a layer 3 IP address. So this operates at layer 2. We're going to go over this a little bit more, but I'm going to put a bunch of links in the chat here real quick. So there are 2 of those links that are related to the OSI model. Again, I'll tell you if I don't think you should spend time studying for something. I do think you should spend time studying the OSI model. It will help your understanding in a lot of other topics and just gets brought up a lot in the industry. So there's a couple links in there that I would encourage you to go through. And then there's another link about ARP that's an article, and then a couple of videos as well for ARP. I don't know why. I've always found this a really interesting protocol. I don't know why. There's no reason for it. It's just interesting. So because you guys, unfortunately, are subjected to my whims, we'll spend a little bit of time on ARP. So this graphic might be a little distracting. We're going to go through this again after maybe one more question. But let's walk through what is going on with address resolution protocol. So in this example, which is from Geeks for Geeks, it's in one of the links that I shared with you guys. We're PC1. We have an IP address, but we don't have the MAC address for a device that we want to communicate with. First of all, why would I care about a MAC address if I'm trying to communicate? Doesn't most of this communication take place using IP addresses? Who's got an idea of why we would even care about a MAC address in network communication? Anyone got an answer?
Layer 2 understand MAC, only MAC.
Say that one more time, Shravan. I couldn't quite hear you.
The layer 2 devices understand only MAC.
Yeah, layer 2 only can use MAC. So with a MAC address, a switch could take care of all of our routing for us within a network. ARP is used internally within a LAN, local area network. 9 times out of 10, there are ways that we can use proxies with ARP, but it's very uncommon. So I don't want you to really get distracted by that. What ARP is doing, we have our IP address. PC1 wants to talk with another one of these PCs. So it's going to send out an ARP request. It's going to say, okay, I have this IP address. Who has the MAC address that it belongs to? It's going to send that request out in broadcast. So it's going to send it out to the whole domain using the broadcast ID of a network. Just because we're talking about it, who can tell me what the broadcast ID is of this network if it's just using a /24 subnet? What's the broadcast ID for this?
.0.
Say that one more time, Paul.
.0.
So you're close.
I'm sorry, 255.
255.
I always get them mixed up.
Yeah.
I'm sorry.
So if you're not comfortable with subnetting, don't worry about it. We're going to cover it another time. There are 256 IP addresses that we can use in a standard WAC24 subnet. Ignore what that means. We have 256 addresses that we can use on a normal network. 2 of those are not addressable though. The very first, which like Paul said was the .0, is the network ID, and the very last IP, so not 255, that's the broadcast IP. So when this PC wants to send out the ARP request, this is the IP, who's got the MAC address it belongs to, they're going to send it out using the broadcast IP. And then that's going to get broadcast around the domain. Who has this IP address? Whoever does responds back. Hey, this is IP address. Here's my MAC address. And then they're going to update their ARP cache or their ARP. And we're going to take a look at this because I think it's fun and you guys are at my whim again. So let's, first of all, these are the links that I sent out. The Geeks one, really good explanations of the layers. Spend more time than you think understanding the layers. I wish I had understood them more, and I still wish I understood them more than I do. We went through that one. We went through this and this and this. Okay, let's spend a couple of minutes talking about ARP so that we can get comfortable with this because we want to understand the layers. We want to understand how caching could potentially play into this as well. So I think you guys all kind of nailed this. Did I actually give you guys the answer? I don't think I did. Is this the question I launched?
This is a new question.
Yeah.
Back up. I skipped the question. Layer 2. Okay. We have one question I'm excited to get to. Let's just do it now. We're going to do it now, and then we'll come. Thanks for your patience. I got excited on ARP. Okay. One more question is coming up. Then we'll go spend a little bit more time on it. So get yourself ready. Okay. Go for it. Oh, you guys are all getting this one. You should. Good job. Couple more seconds. Okay. Nicely done. Nicely done. You'll notice we have some very similar words coming up here that we had in our DNS conversation. So we poisoned a DNS cache. Boy, some of this is starting to look pretty similar. Well, we have an ARP cache, okay? And we're going to try and put false ARP data into the ARP cache. When a system tries to send traffic using that ARP cache, it's going to get sent to the attacker, or in this case, the pen tester's system. And you guys nailed that. It's ARP cache poisoning. So let's walk through these to identify what they are. First of all, reverse address resolution protocol is pretty much deprecated. It's deprecated by protocols like dynamic host. Oh boy, what's the C in DHCP? Configuration protocol, dynamic host configuration protocol. I get that? Someone correct me if I got that wrong.
Yeah, I think that's it.
Thank you. So that's what we use now as a replacement. ARP was used when we didn't necessarily have ways of getting devices that had a MAC address but did not have the memory to sustain an IP address or weren't networked at layer 3 but still needed to get an IP address. That's what that was for. Now we have DHCP. It automatically passes down IP addresses when something wants to join the network. So this is deprecated. We can do flooding. We can do ARP and RARP flooding. It's not a very effective attack, though, because a lot of encryption protocols have defeated this in general. So this is, if you have good encryption on your system, for the most part, you're going to be able to defeat these sort of attacks. A denial of ARP attack, I won't say you couldn't do a denial of service on ARP just by flooding a network with broadcast, but that would be more of the flooding. And then ARP buffer blasting. That's just made up. That's just made up. So, okay. Let's go look at some visuals here. So we've got a couple PCs. We've got a server. We've got a printer. We have a layer 2 switch, and that's connected up here to a router. So let's just walk through one more time what ARP is doing, because it's an important protocol, and I want us to actually see it too. So what's going to happen? This PC wants to print something. It wants to print something. It maybe knows the IP of the printer, but it also wants to know the MAC address, because it needs to route things within this network. So how does it know, first of all, that it's within its network? Well, it can use the IP address and then its own network information, like its subnet mask, so that it can first identify, does this traffic that I'm trying to send, is it local? If so, then I want to try and use the MAC address. It's a lot faster, could be safer, doesn't need to go outside the network at all. The network could be down externally and it can still communicate internally, no problem. So there's other reasons we might want to have this happening. It's common for routers or switches sometimes to use ARP so that they can update their cache. They have a table that they would maintain, an ARP table. So what happens? This is the message that is getting sent out. This workstation is going to broadcast out to the whole domain. And the way that works is they're going to send this ARP request up. It'll usually go to the switch. It'll go to whatever its kind of gateway is or wherever it's the next networking point. And then this switch is going to broadcast it out to the domain. So everything that's connected here is going to get this same ARP request. And that request is, who has this IP address? I need your MAC address. And it'll give its own information too, so that the workstation knows how to respond. So we send out all these ARP requests. Well, the printer gets it and looks at it and says, boy, that IP looks pretty familiar. That must be me. It'll send a request just to this, just a direct message. We're no longer broadcasting, and provide the MAC address. So, April, yeah, go ahead.
So are you saying that ARP doesn't leave the network? I mean, it doesn't leave the internal network?
Yeah, I would say, yeah, it won't leave the internal network. It's a local area network technology or protocol that we would be using, because we're wanting to identify things at the layer 2 level, and we won't communicate outside of our network using anything below layer 3. Not in that sense. There are layer 3 switches. We can still use ARP and layer 2 to communicate with this and also have it be capable of IP routing. So that is an option, not the one we're exploring today. But yeah, really good question on that, April. Okay. I like to be able to look at this stuff when we get a chance to. So let's look at an ARP packet. I'm going to share another screen with you. And we're going to take a look at Wireshark. If you have not used Wireshark, go download it. It's free and it's a lot of fun to play around, and boy, it's a good learning tool. It's also great for a lot of other things, but it's great for learning too. So in this interface here, I'm going to select Ethernet 2 and I'm going to start a scan. What's going on right now? I'm capturing the traffic that's going on this interface, and I'm getting the raw packets. This is just amazing. This is absolutely mind-boggling to me that we just get to look at this stuff. Look, there's a hexadecimal. How cool is that? So let's stop this packet capture and let's go find something with ARP. There is a way to search by protocol. My Wireshark syntax is not great. So if you scroll, we should be able to find, there we go. There's some ARP requests right here that we get to look at. I don't know if I can zoom in.
So this is on your network at the moment?
Yes, correct. This is on my own network.
Cool. And
if you can do this on your own network, you will absolutely see ARP requests. So this is what it is. Let's look through it. Who has 192.168.8.215? Tell this. This is my router right here. My router wants to know the MAC address of this particular device right here. You can see it also wants to know the MAC address of this other particular device. Now we see an ARP here that's a response. So my router asked, who's got 244? 244 responded with their MAC address. This is just, I think it's so cool when we can study this stuff and then just pull it up and look at it. Who has the IP address? Tell me. Or yeah, who has it? This is a little bit different. Who has that? And here's the MAC address on here. Sandra, you had a question?
Yeah, I just kind of got confused for a second because you said ARP is handled at layer 2, but then you're saying the router is asking for this information.
Correct.
So that's where I'm kind of lost.
Really good question. Yeah, absolutely. Really good call and question, because my router is layer 3. So what's it doing hanging out on layer 2? Well, my router is also a little switch, kind of. It has a pretty small network. It's just one of those little tiny GLI routers that I use for my office. So it has a lot of different purposes. And routers can also use this protocol because they want to get a sense what's on my network. If something reaches out to me, do I know where to send it inside the network without having to go outside the network? It can operate at layer 2 as well internally. When it needs to look outside the network, then yeah, we'll bring in that layer 3. But the router wants to know MAC addresses as well. Does that answer your question?
Yes, thank you.
Awesome. Just because we're here, got to poke through these. We have frames. Oh, I wish we had time to go through this stuff, guys. It's just so fascinating. Look at the amount of data that's in a single packet. I just think this is too cool. Okay, we can tell the frame length that's on here. Let's look at Ethernet 2. This is layer 2. Here's the destination, GLI Technologies. This is my router here. The source, where is this coming from? So you can tell this is the brand. So MAC addresses, we didn't actually cover the fundamentals of what a MAC address is. I think our next question touches on that a little bit. But a MAC address is assigned to your hardware. Typically, and someone correct me if they have a better answer for this, is it the first half of a MAC address or the last half that's kind of a manufacturer identity that's a little bit more?
I think it's the last half is the unique identity identifier, the last.
Perfect. Okay. So
yeah, I thought it was the first, but not the first half, but like the first quarter of it.
The first half will be specific to the manufacturer. So if we found something else from GL Technologies, it would probably have the same first half of this MAC address, and each device will be look a little bit different at the end. But it's a unique identifier. We can spoof MAC addresses. We can pretend that we're using a MAC address that isn't actually on our hardware. But that's where that is. So let's see if there's anything else. But yeah, from that, it also gives us a sense of what the manufacturer is, I guess is my point. If we know that this, or have a good idea that this is a GLI Technologies router, because of the MAC address that we get. So we get some extra information too. And then here's ARP down here. This is a reply that tells us we're going over IPv4. This is the sender and the target. The sender itself, I think this is my workstation maybe, I'm not totally positive, but it's going to then respond to my router, the router being the target. So if you look at packets, it's usually source and then destination. Here's me going to you. So that's typically how we see it there. Let me go back to our window here. Same sort of concept with source and destination that's getting communicated on here. We don't see that in the same way in this terminology. Who has this? I am this. It's but that's the concept that's going on behind the scenes. Okay, does anyone have questions on ARP before we move on? We have another question that I think might touch on a little bit. Does anyone have any questions though first before we go on from ARP?
Just what is the countermeasure for this?
Say that one more time for me, Sravan.
What's the countermeasure? Like, how do we control this?
The countermeasure, encryption, is one of the biggest ways that we can do this. So with ARP, we have to protect our DNS server. We have to protect the cache. That's really important as well. But to defend against ARP attacks, we do have to have encryption. Let's walk through why. brought up a great point because we can look at a man-in-the-middle attack using ARP if we were sitting on an unencrypted network. April, before I go into that, did you have a question?
Yeah, I would say we can also protect it by a subnet, right?
Yep.
That's in the DMZ. But would that be one of our servers, like in the DMZ or ARP? No, it wouldn't, because it would sit outside.
You nailed that. Exactly right. So we would want it wouldn't be an ARP server.
Or the DNS server would be in the DMZ zone, but not the ARP.
Yeah, very well could be. It kind of depend on the organization, but yeah.
Okay.
Let's look at a man-in-the-middle attack. So we understand how ARP works. I want to talk to another station. I send out a broadcast asking who that station is, and they send me a reply with the information that I need now to establish a communication. So what happens if something bad joins the network? And actually, let's change we'll leave it as a workstation. What happens if something bad joins our network? Okay, we're now in a coffee shop. My brother owns a coffee shop. Let's say he has unprotected Wi-Fi. He better not. This station, when it joins the network, has every right to communicate via ARP once it's joined the network. So it could say, I want to communicate with this workstation. I'm going to send out an ARP request. It could also send out ARP replies. So this workstation wants to talk to this workstation. So it sends out a broadcast, goes out through the whole domain. Who has this information that I need? Send it back here. Sends out the ARP request. Every workstation on this domain is going to get that request. Not the domain, excuse me, the network is going to get that ARP request because it's broadcast. So this computer is going to send an ARP reply with their information. There is nothing preventing our hacker over here from also sending an ARP reply claiming to be that workstation. In fact, we could try and Paul's putting Evil Bob, exactly right. I switched to a new tool and forgot to bring Evil Bob over with me. He'll be here next week, Paul. So we can send our own manufactured ARP replies claiming to be something that we're not. This is spoofing in a way. And it's also sort of trying to poison the ARP cache. Because if we send a bunch of these replies, there's not a lot of validation that's going on. It'll send an ICMP packet, a ping packet back here to validate the connection, but the attacker can still be spoofing us. We don't really know. So encryption is a way to defend against that attack. But this attacker, the different attacks that they could do using ARP, first of all, sending fraudulent responses, trying to become a man in the middle. If he gets this workstation to believe this is the correct IP, then any packet, let's just do oops. Here's our packet. He wants to send a packet here, but the ARP cache has been poisoned because this guy sent out so many ARP requests or ARP responses that were fraudulent. So instead, he sends it here because his cache was poisoned or his cache was poisoned. So now he could just forward this along here. He's a man in the middle effectively at this point. We could just put him right here. Any traffic that he wants to send over here, I don't know why I'm using my ARP box, that he wants to send here goes through here because this workstation doesn't actually know the correct location of this. The information has been spoofed at this point. The cache has been poisoned. So that's one of the attacks that you'll see. ARP flooding, again, this is kind of a deprecated attack, but it still is a legitimate attack. This guy could just start sending out requests and responses, just blasting them out there, trying to overwhelm the network, trying to overwhelm individual caches even as well. An attack that can happen, and this is true with any cache that we're attacking, is there can be boundaries that are set on that. A cache has a size limit. If we exceed that size limit, what happens? A couple of things can happen. Who can tell me what fail open or failed closed are as just conceptual from a security standpoint? Tell me a little bit about what fail open versus fail closed means.
Fail close means that it stops if it goes wrong.
Exactly right. Think of, okay, a bad place to use fail close would be fire doors. Okay, if the power goes out, I don't want to have all my doors locked. They need to fail open so that people can get out in an emergency. Let's think of what would happen if we had a fail open on our cache, our DNS or our ARP cache, doesn't matter which cache it is. If we overflow those boundaries, we might start to hit a fail condition on this switch, even on our individual workstations. Maybe it's a fail open situation where if we overwhelm the cache, it's just going to start saying, okay, I can't handle this. I'm going to send it out everywhere I can and hope that it gets there. That's a legitimate configuration. It's the wrong configuration for this use case, but that's a legitimate use case. So there's ways that this that flooding can be used as an entry point to other attacks. Here in this example, this is combining a couple of attacks because we are using flooding to, maybe it performs a denial of service. We're more focused on poisoning the cache and eventually overwhelming the cache. This is sort of like a buffer overflow attack too, but we're hoping the buffer overflow will trigger some other condition, like a fail open. So there's a handful of attacks, and attackers will just chain these together to find what works. I'm going to throw stuff at you until I know what mistakes you made that I can take advantage of. So those are a couple of the ARP attacks. Does anyone have questions on this before we go do another practice question? You guys are doing great, by the way. Really, really wonderful questions.
So your brother hasn't asked you to check his network?
He has, actually. He has, which is why I know it's encrypted. So yeah, good question. Good question. Yeah, Sandra Patterson.
Yeah, so if I'm understanding correctly, you're saying that hacker can then overwhelm by sending all these messages to then flood it, and then after it can possibly open it to then
yes,
further damage, like further attacks.
Yes. Let's just walk through this slowly because actually for maybe the first time ever on study group, I'm doing okay on time, which is surprising. So let's walk through this. Let's have this be our cache. Could be DNS, could be ARP. The bottom line is that these sort of networking devices, they have an internal cache to help them make decisions. So we're going to try as attackers now to take advantage of that. So we're going to chain some attacks. We're going to use ARP first to try and disrupt the network. There's a lot of different attacks we can do. Let's try this one out. So instead of using the normal protocol, which was, okay, I want this workstation, I want to talk with this station, I'm going to send out one ARP request, and it's going to get broadcast out to the whole domain, and then I'm going to get one reply from the workstation I want to talk to. Well, instead of sending one of those requests, I'm going to send, just keep sending them. Just send ad nauseum, I just keep sending them. Well, this is going to start to add some latency into the network. But what happens when some machines start to resolve to this? Well, our cache is going to start getting filled up. That's one aspect. So let's take a look at the reverse. Instead of flooding the network, let's focus more on getting a man-in-the-middle condition or poisoning the cache, both of those. So instead of flooding the network, this workstation wants to communicate with this workstation. So they're going to send out their ARP request. Where's my ARP? ARP request goes up. It's going to go to the layer 2 switch. The layer 2 switch is then going to broadcast it out to the entire domain. Even Evil Bob. Here, hold on. Where's my text box? Oops. Just for Paul. Evil Bob is going to get that same ARP request, and he's going to reply. Even though we were trying to talk to this workstation here, there's nothing saying he can't reply to that broadcast. So while this machine is also going to send a response, Evil Bob is going to continue to send responses as well, trying to overwhelm this workstation, essentially until it says, fine, I'm going to put you in my cache. You're the right IP, you're the right MAC, I get it. You've sent me 100 ARP replies. It's basically just going to try and overwhelm this. There's a lot of attacks that happen on this foundation. Wireless attacks, super common, because you can run deauthentication attacks and force someone to try to log into a network again. and you get to capture that process over and over, helping you get in. So these are amazing foundational concepts. When I say cache, when I say ARP, when I say DNS, the same principles apply to a lot of other areas in cybersecurity. So, oh, there's a hidden title. So this machine sends back one reply, but Evil Bob sends back 100. And finally, this machine decides, I'm just going to update my cache. This is the machine I want to start talking with. Well, we've created man in the middle. We've definitely breached confidentiality if we don't have encryption, for sure. We've breached integrity because Evil Bob can make any changes he wants to this and then send it to where this workstation wanted it to go. This workstation doesn't know. How would it? And maybe we've poisoned the cache for this workstation as well, sending ARP replies to it, maybe even unprompted, trying to trick it into understanding that Evil Bob is who I want you to talk to, not this other guy. I better just put Bob and Alice because I keep talking about these workstations here. Whoops. This will just be regular Bob. I mean, he's not just regular, he's pretty cool. And then Alice. So now we have done this. Evil Bob has a man in the middle situation going on. He's in the middle of Bob and Alice's communications because effectively what he has done by poisoning the cache, DNS cache, the ARP cache, in this case, let's still stick with the ARP, sticking a layer 2. He's essentially told all these other workstations that I'm the guy to go to for whatever IP you want to go to or whatever MAC address you want. So, okay, I want to print something. I send out an ARP reply. Well, turns out Evil Bob is the printer, and he's Alice, and he's a server. Anything Bob wants to do now goes through Evil Bob, depending on the level of poisoning that he has done to the cache there. So let's take this a step further, since we have time and are getting a little sidetracked. We've poisoned the cache. Now we could do spoofing if we wanted to. So we've taken over some device communication at this point. Maybe we want to start escalating. We can continue to send different types of requests to start tricking the layer 2 switch. Once we have poisoned this cache, we can, we were going to go towards the buffer overflow. Let's move in that direction instead because I had brought that up already. So we are going to send out these responses, these fraudulent responses, trying to trick all of these devices that this is the device they want to talk to whenever they're initiating a conversation. So they're trying to create man in the middle. One of the other things that could be happening when they're sending out these is, like we talked about, the cache table could be getting filled up. So let's put an IP address. Oops, that tab doesn't work. And a MAC address. Then that's a MAC address. And we'll ignore these 3 columns here. I'm still kind of new to this, so I'm not. Okay. And we have another address. Okay. And let's say our cache is completely maxed out. So our cache is completely full. Bear with me, those are all MAC addresses. What happens when he sends the next one? Well, now we're overflowing the limit that we have on this cache. Could just be a storage memory issue. Could be a configuration issue. Doesn't matter. There's a limited size that is needed for business circumstances for a cache, and then we can overwhelm it. So we've overwhelmed the cache. Now we're looking at that fail open versus fail closed scenario of I don't have enough space to handle any more of these ARP replies that you keep sending me. So I'm just going to open up the network and stop routing traffic that way. So that's kind of how those attacks work. That's a little bit more of a tangent, just to kind of give you a sense of the principles that are going on here. Does anyone have additional questions they'd like to touch on here? So we've only got a couple more practice questions, so we're doing okay on time. Yeah, April.
Can you explain ARP spoofing? I think you touched on it, but in this case, like, I get the ARP poisoning and everything, but ARP spoofing is when they change the ARP ID address. Is that's what happens when?
Yeah. Yeah,
Okay.
good question.
Okay.
You use the terminology, the correct terminology to say exactly what we just did here. So we
Oh, okay.
one response where they are flooding a network. That wouldn't be spoofing necessarily. It is kind of spoofing. But when Bob sends something to Alice, excuse me, when he sends an ARP request and it gets broadcast out to the whole domain, Alice is going to respond with something legitimate. We're going to respond with something that is spoofed. So we're going to spoof, in this instance, her MAC address, and we're going to pretend to have the same IP address as requested. So Bob wants to know, or has Alice's IP address, and he wants her MAC address. We're going to spoof our ARP response and include our own MAC address for that communication. The next question actually has a little bit on spoofing. I think it was on MAC spoofing specifically. ARP spoofing, I wouldn't focus on that because ARP spoofing is what's taking place here. We're spoofing an ARP reply, but the attack that's happening is we're poisoning the cache, or we're trying to accomplish man in the middle. So again, spoofing, a little bit more of a broad term to talk about with this.
Okay. Got it. Thanks.
Yeah. Sandra, you have a question?
Yeah, I know you want to move on to the other questions, but you mentioned earlier, and sorry if I missed that, if you explained it, but to address this, we would do encryption.
Yes, absolutely.
So how does that work when you're broadcasting everything and people are trying to find out whether, you know, this belongs to me, this IP?
Yeah, let's take a couple of scenarios there. First of all, let's take my brother coffee shop example. So they have it's not an open network. They just have one key that they provide to their customers. They have separate networks, but they have one key. So it's not hard for Evil Bob to join the network here. So he can do that. When you are on an open and public network, like in the coffee shop example, you are not protected because your communications that are going on behind the scenes are unencrypted for the most part. There's a lot of communications that is getting migrated to just default encryption, which is wonderful, but I'd rather you assume that it didn't. So if your Evil Bob is on my brother's coffee shop website, he can see anything that Alice and Bob are doing. We could use something like a VPN, which encrypts our traffic again over the network. So we maybe have encrypted traffic here, but Evil Bob joined our network. He's allowed to in this situation of a coffee shop. So Bob and Alice need to have another layer of encryption that is going on in order to be protected from this attack. A VPN is a great answer here. It's not the only purpose of a VPN, but it will hide your communication and make these sort of attacks impossible, or impossible at least in the way that we're talking about them. So let's take another scenario. Let's take a corporate network where you need credentials to join, or like maybe using Radius. I think we talked about that a couple of weeks ago. So these devices get authenticated to the network. The protection that we would instigate in that point is, there's a couple that we could do. First of all, Evil Bob has a challenge just joining the network. If we're using a Wi-Fi network that has extra protections like that, not just a shared key, authentication that's going on, Evil Bob would have to authenticate in order to be on that network. There are other protocols in the background that can help secure the ARP communications. Mostly it has to do with determining authoritative sources. We've used that term. I mean, we've used it in DNS. We use it in certificate authorities recently. We have authoritative devices on our network that we can secure a little bit differently, saying when you get information, this is how you validate that information, or what's required in order to accept new information. So it's a little outside of the scope of this conversation, but does that kind of answer your question there, Beth?
Yes.
Yeah, okay, good deal. And don't apologize for answering questions. I would so much rather answer questions than anything else. So, okay. Next question, get yourself ready. I'll pull up my timer here. Okay, go ahead. Oh, I didn't launch it. Okay, poll is launched now. Couple more seconds, get your votes in. Okay, nice. Very well done. Just about all you got that. Spoofing and address conflict. Okay, so let's walk through this. Sue modifies her MAC address. First, can we do that? Is that something we can actually do? Can we modify a MAC address legitimately or illegitimately?
I've heard of ways of it being done. I didn't think you could do it because my understanding is the MAC address is hard coded to each device, but I guess there's ways to do it.
You're exactly right. Legitimately, no, there's not really a legitimate way to change your MAC address because, as Paul called out for us, it's assigned to the hardware. So unless we're changing hardware, we don't have a reason to change MAC addresses. There are legitimate uses of MAC address spoofing, but taking a step back and looking at it from information security, it's not a legitimate practice. We're pretending to have a MAC address that is not ours. There are legitimate use cases for that, especially with, that's a sidetrack. Okay, so modifies her MAC address to one that's allowed on a network that uses MAC filtering. MAC filtering, interesting. Okay, we talked about whitelisting and blacklisting earlier of MAC addresses. This could very well be the case that's going on. So if you work for a small employer, or it could be a large employer that actually practices good asset management, they could say, I'm only going to allow, I'm going to whitelist these MAC addresses on my network. If the device tries to join and it doesn't have that MAC address, don't allow it to join. Really good security principle, but spoofing is not that complicated to do, actually. So good security measure, but not sufficient. So what technique is Sue using? You guys nailed it. It's spoofing. We're pretending to be something or to have something that we are not. We're pretending to have a MAC address that we don't. We're going to mimic one that is allowed. So, and then the address conflict. Absolutely true. If she picks out a MAC address that is already on the domain, that's going to cause some issues because she has a MAC address that might conflict with another. It's a little unlikely. But if it does, then it would be easy to start having IP conflicts as well, which is a lot more serious in networking. So looking through this broadcast domain exploits, not necessarily. If we were talking about the use of ARP to do some things, then yeah, we might be talking about a broadcast domain exploit because that's kind of what these ARP attacks are. Address conflict, yep, we see that down here. Spoofing is correct. Token loss, not quite what we're referring to here. We talked about tokens and their relationship to authentication, but whitelisting and blacklisting are a little bit different from an authentication perspective, not quite in the same ballpark. Sham EUI creation, I don't know, did I jot down something about what that is? I'm not sure what that is. It is related. Sham, so fake. I think this is related to the hardware ID code, but I'm not sure. Does anyone know this acronym offhand? I always tell you to study the acronyms, and here I am not knowing one. And then token loss, kind of same deal. More related to authentication mechanisms there. So that's spoofing. Okay, I think I got one more question ready for us. So get yourself ready. And go ahead. Those of you who have been with me for more than a session or two know exactly what advice I'm going to jump to after this. Couple more seconds. Get your votes in. All right. I'm going to put the acronym in the chat just so you have it on here. Who knows, without me even having to say it, what advice I'm about to give about test preparation? Who's heard me say it enough times already?
Forget about the question. Just look at the answers.
That's definitely one of them. That's definitely one of them. One of my other test tips is to study your acronyms. Study your acronyms the day before and the day of. Find a list of 1,000 of them and go through them. Because one, it will speed you along in the exam greatly. Two, sometimes if you don't know the acronym, you're going to be taking a completely wild guess. And three, a lot of time the acronym, knowing what it actually is all you need to answer the question, which is exactly what the case is here. Yeah, Sandra Peterson. Yeah.
Just on that, is there some sort of cheat sheet that's got maybe a set of acronyms that's worthwhile to know for each of these domains? Because I know there's a lot, but is there something that says these are the ones that you should definitely, you know?
It's not a definitive list, although someone did ask that recently, and I told them that I would put together a list that I've used over the years. I typically have found them, honestly, just from the back of textbooks. So I have my Security Plus, my Network Plus books. I'll go out in the back. They have an acronyms list there, and I'll use that. There's a couple other resources that I've used, but that's probably 80% of where I would get the acronyms that I want to study for. I find a certification book and check to see where its acronyms or its glossary are. But I will work on a list. I'm going to jot your name down to that question as well, just so I can.
Yeah, that's just I suppose just to cheat to say that these set are worth definitely knowing and memorizing, and also understand the concepts and everything around it.
Yes, absolutely. Yes, Chris was the one that asked that before. So Sandra.
Thank you.
Absolutely. Yes, an acronym list. So know your acronyms. I know I already put it in the chat, but did anyone know SPIT offhand? I didn't. I had to look it up again. I couldn't remember. Oh, and Sandra shared a sun. Oh, yes. Forgive the distraction from the question. Sandra just put a link in the chat that has been highly recommended by one of the people that in our group that has passed the CISSP recently. Thank you for putting that in the chat, Sandra. I appreciate that.
No problem.
Okay.
It's helping me.
Good to hear. Good to hear. So SPIT, spam over internet telephony. With just knowing that, if you know the VoIP acronym as well, voice over internet protocol, it becomes an easy assumption to think that they're going to be linked up. We have phone in the name of the attack, and we have, voice over IP. VoIP is usually with phone systems. So we have them linked here pretty quickly. So if you know the name, or excuse me, if you know what the acronym means, you can have a really good guess at what this is. So virtualization platforms, not really relevant here. We can have virtualized phone systems, but that's not what we're really focusing on here. Web services, exactly the same deal. We are communicating over the web, and we are using web services to accomplish our attacks, but VoIP systems is going to be the most accurate answer for this. This is just a filler. It's not a real thing. I don't think so, unless there are a lot of acronyms, so it's possible I don't know this one. Okay. I think that might have been the last practice question I had. So, okay. Oh, look at that. We got 3 minutes to go. You guys who've been with me for more than just a little while, I know this is the very first time we have ever ended early, and we can still hang out until top of the hour. So because I have the opportunity to do so, thank you. I really appreciate you guys being here. You're asking really good questions. I can tell you're studying. I can tell you're thinking about things the right way because you're asking such good and engaging questions. So please keep that coming. I'm going to put the link one more time into the chat for where you can go to submit practice questions to me. I love getting them from you guys. Your practice questions are better than my practice questions. I would rather go through what you would like to go through than what I think would be good. So I'm going to put that link in the chat here. Those go directly to me. Otherwise, just keep engaging. Keep engaging with the school community. If you have not gotten involved there's just amazing people, and they're passing their exams left and right. It seems like once a week I log in and someone else has passed. So let them be an encouragement to you.
Josh, sorry to interrupt.
Go ahead.
The sessions that are held on Thursday or Thursday morning, are they similar to this one?
Yes, great question. Oh, holy cow. Sorry, I got distracted. I'm trying to put this in the chat here. Yes. Thursday morning sessions are pretty much just a repeat. It's Josh presentation 2.0. So there's usually a couple little improvements, or I might swap out some questions if everyone was getting them correct. But for the most part, they're a repeat session. We are considering doing 2 sessions that are distinct again. But we're going to wait till I'm out of school before we dive in that far. So yeah, good question. You're welcome to come, but mostly it's a repeat of content.
Awesome. Thank you.
Yeah, absolutely. Anyone else have questions or shout outs or anything they just want to chat about? Holy cow, we still have a minute. Man, we have gobs of time. We've definitely gone 30 minutes over. We've never gone 30 seconds under. So thanks, Paul. I appreciate it, man. You've stuck with me through a lot of late ones. All right. We'll wrap up there. Please reach out over school, instant message me, anything like that. Really proud of you guys. Thanks for showing up, and look forward to seeing you either next week or on Thursday.
Thank
Thank
you.
Josh,
Thank you.
much appreciated.
Thanks so much.
Thank you.
Thanks. Bye.
Bye.
Josh, can I just ask, which isn't related to CISSP,
Yeah.
but if you're leaving your university to do this, like this isn't a paid group, aren't you gonna be poor? Aren't you gonna not be able to eat?
You nailed it. Yes.
Well,
Yeah.
I appreciate you being poor for us.
Yes, I have a full-time day job. The university is a part-time job that I was kind of experimenting with to see if it was going to be a good fit.
Oh, I see.
This is a volunteer type of a deal, but we are looking at launching our own boot camp potentially in January. So it's completely free, and there will always be these free study groups that are available. But the founder, Vincent, I don't know, he maybe reaches out. Sometimes he reaches out to new members.
He sent me a message.
Oh, great. Yeah. Yeah. Hopefully you pointed you towards the YouTube video where you are able to see kind of the recordings. But yeah, we're looking at trying to develop an in-house boot camp that's kind of hybrid. So a few hours a week in the evenings, not necessarily all live. Because that's one of the questions we've gotten quite a bit is, I know I need to be studying, but how do I know I'm ready? Or what plan should I follow? So we're just looking to formalize that structure.
Yeah, that'd be awesome. It is very overwhelming. So yeah, it's good to have all the extra help. But I'm glad you also have a full-time job. So
Me too. I wouldn't be able to do this without it. So yeah, no, I'm really glad you were here, Adam. Thank you. I was a lot of fun having you. You asked some great questions.
Awesome. Thank you so much.
Absolutely. Yeah. Annette, do you have a question?
Yes, I am. So I've been studying and everything. I took the exam. I took one of I have a Udemy for free at work. So I took one of Thor's because I decided to go for the cybersecurity. It says it's free and it'll be something like it'll prepare me for the CISSP. But I took one of the exams, right? Thor's exams, and I made a 68. Like it's kind of frustrating.
Okay. Is this for the CISSP or the CC?
The CC.
Okay. Yeah. Don't be discouraged. Don't be discouraged. First of all, if you were to take the exact test over again, chances are you would score very differently. Could be higher or lower. I remember that being so frustrating when I would study, because I would study a domain, I'd go take a practice exam and my score would drop. Or a domain that I scored really well on would drop. Or a domain that I had no confidence of would just jump for some reason. Is that familiar? Is that
yes,
kind of what
very.
All I can say is it's frustrating, and you're looking more for consistent growth over time than any specific metric. So you're going to be growing your own confidence, your own internal confidence level. So you get a 68 or something like that, whatever you said on the exam. Okay, adjust your confidence level to 68, maybe. Take another exam and get a sense of what you do after maybe 2 or 3, I would say is what I would try out for that. But again, it's hard to get consistent exam scores like that, unfortunately, with the practice tests, especially given the range of sources we often have for those types of questions. I know that's one of the reasons we share so many providers of practice questions, because you might knock it out of the park using one person's test questions and then get completely stumped on the same domain using someone else's questions. It's
frustrating because I did Mike Chappelle's one, the one that wrote the book, right?
Yeah.
And I did his, just to see where I'm engaging at, right? 68 as well. Like, it's like, I'm like, really? Like, but I'm just going to keep on working at it and see. I have to take my exam because I passed that Forgive I went ahead and bought that, the package, right? So I have
Sure.
to take it December.
In December?
Yeah, the CISSP, the actual test. But then I'm just gonna do this one. I gave myself like about 3 weeks to study and then take it.
Yeah.
The CC, that way I can just continue with my CISSP.
I think that's a great plan. A couple of people have mentioned that same process of kind of having an intermediate step before going up to the CISSP, start to get a sense of what practice or what real test questions you're going to expect. Great confidence builder. And you're never going to regret having taken it, even if you fail. Fast forward to worst case scenario and you fail your CC. Well, now you know. I would rather know that I'm going to fail than go in with not a lot of confidence. It would give me a better sense of what I need to study or focus on. So view it that way. You're taking an experiment. You're going to take this exam coming up. Did you say you had the CC exam already scheduled?
Not yet. I'm gonna schedule it, and I'm gonna do it 3 weeks, and then that's it. Because I have to continue with my CISSP.
Absolutely.
And I was talking to my manager, right? Because he's like he's going for a CISSP, but he's like, it's so boring because he's government, right? Because he's been a manager for a long time. He thinks like a manager. He's like, so he's taking a year-long course for CISSP. He goes, it's so boring. He goes, everything's boring for me because I kind of already know this.
Yeah.
Like, yeah, and me, I'm trying to like switch my brain from a technical, because I've been a technician for years, to manager, right? So me, it's like, it's that's been the challenge for me. Like,
yeah.
And he goes, you got to think like a manager. He goes, there's no way you're not gonna pass. You're gonna pass this exam if you don't think like a manager. Like you have to.
Yeah. It is challenging. I'll give you just something that I think is helpful when you're studying, especially when you're trying to make the transition from thinking like a technician to thinking like a manager. It helps to start interrelating different concepts to each other. It's rare that we get a question that is, you only have to know one topic from one domain in order to get it correct. Usually it's a blend of things. There's a business environment that this technology is being deployed in, and we have a specific use case. So when you're studying, if you have a term like ARP that you're trying to understand, knowing what ARP does of translating IPs to MACs and communicating that over the network, that's good to know. But a manager doesn't care about that. He wants to understand, what do I need to do to defend against an ARP attack? If I'm going to make an upgrade, do I need to be concerned about this if this is my architecture? Or if I see this attack, could it be this that's going on? So trying to interrelate those concepts or thinking of them within a context that you're most likely to see them in as a technician even can be helpful, just because it really does reinforce your thinking of, I don't only just need to know the technology, I need to know the context. Where does this actually fit in the real?
We need to know both. We just had an incident. I work on. I do DevSecOps. I'm an IT operations, right? So we get tickets, right? And we got to resolve them. And we just had an incident where the company, one of the companies, because we're a collaboration of 80 or more contracting companies. So one of the companies decided to go ahead and upgrade their encryption. They said, "Oh, everybody's compatible. That's fine. We'll just encrypt it. We'll just go ahead and switch it up to SHA 286."
Yeah.
And so they broke all their, so none of their employees can get into our platform because they broke the encryption. So it's not doing any nuance resolution. Like, we don't do nuance. We do something else. We don't work with nuance.
Yeah.
So and then they were asking, well, can you just go ahead and can you go ahead and use OSC? We don't really use OCSP, right? They go, can you just use OSCSP, just to cater to us? They're like, no. They told me, hard no. They told like that. So they have to go back and redo what they did because no one can get in. And they're telling us, hey, I'm getting X509. I can't get in.
Yeah, absolutely.
We can't, I can go ahead and send you the link to update your certificate, but there's nothing else I could do, right? Like, we're looking into it at first, we're troubleshooting it, and we're like, hey, everything's good on our end. Has to be something on your end. And sure enough, that's by the way, we updated our SHA to our encryption to SHA 286. And they're like, oh, well, that's nice, but we don't use that.
Yeah, you don't have the backwards compatibility. Yeah,
you don't have the backwards compatibility. Yeah, exactly. So yeah. That's been fun. Like it's been crazy. That's what I do all day. I like solve problems like that, like different problems. Like we have different stuff that I work on.
That is so fascinating.
Besides DNS.
Yeah, you get to learn a lot doing that, don't you?
Yeah, I do. I it's very broad for me. Like I work a lot with Jira, Mattermost, and Confluence. I do a lot of troubleshooting with them.
Yeah.
Those applications.
Everything you're mentioning is it's perfect study opportunity right where you're working. You're learning about cipher suites, backwards compatibility, you have
Containers.
to coordinate information. Yeah, contain all of those aspects.
Kubernetes.
Kubernetes, yeah. So you can be thinking even just throughout your workday of, okay, this is the technology we're working on. Where does this fit in? What is the context for this?
But I should be, yeah.
Yeah,
So
you're already doing that.
I try to do that. Thank you, Josh, for taking that. I don't want to take too much of your time. I'm pretty sure your wife's like, where is my husband at? But thank you so much for taking the time to talk to me. I enjoy your lectures. You're an awesome instructor.
I'm really grateful to hear that. Thank you, Annette. That's very kind of you. I enjoy the opportunity to get to be with you guys. I really do enjoy it a lot. So thank you. Yeah.
So
Plus, thank you for participating so well. You ask wonderful questions. You always have something great to add to the conversation. It's really nice.
Thank you. I used to be a network admin, by the way, for Rackspace. I don't know if you ever heard of Rackspace.
Yeah, I absolutely have heard of Rackspace. I have some assets in the cloud with them right now. So
I used to be a network admin in enterprise. I used to handle oil like Valero, Tesoro, and I used to handle their accounts. So.
Very cool. Very cool. But it's just some neat organizations.
Everything that you're talking about right now, it brought back memories.
Well, I love that you're able to speak up in these and add to the conversation. You really do, because I have gaps that you fill just so naturally, and that's very nice.
Thank you so much. You have a nice evening. Okay, thank you, Josh.
Doing that. Thank you. See you next week or on Thursday.
I'll be on Thursday or morning because I like to go double up on your lectures.
You're the best.
Thank you.
I'll see you Thursday morning, Annette.
Yes, sir. Thank you. Bye-bye.